we're going to mix it up here and talk about something other than spatial data. We've been talking about spatial data all day, and LANDFIRE has one really great product that's not spatial directly, and it's the biophysical settings models. So what I want to cover today are what these models are, how we use them in LANDFIRE, because they're a very important part of some of the other maps that we produce, how that model set has changed over time, and then how a real-world example of how others have used these models for conservation and management. So first of all, most folks use ArcMap and spatial data and have some level of familiarity with that. Fewer folks use the biophysical settings models, and so I want to spend a little bit of time explaining what that is. So first of all, the biophysical setting, or BPS, is one of LANDFIRE's potential vegetation concepts, and what it's trying to estimate is the vegetation we would expect on the ground, given the biophysical site, which includes things like climate and soils and growing degree days, all of those abiotic factors, plus an approximation of what we think the historical disturbance regime might have been. So that could take, for example, a Doug-fir grand-fir forest to a Ponderosa pine forest in your biophysical setting classification. So it's that inclusion of disturbance that's really important with the BPS. And so the set of models that we produce to represent these biophysical settings that get mapped are state and transition models, and they have an accompanying description document. So this is a pictorial description of the states in a state and transition model. This is a Northern Rocky Mountain Ponderosa pine system, and this system is represented by 5 different cirral stages or states on the landscape. So in the center, you have an early cirral post-disturbance state. We have 2 open states, a mid and a late open, and then 2 closed, a mid and a late closed. So that's a typical way that we model our forested systems. Now there are successional pathways between these different states on the landscape. And because this is a fire-maintained system, the dominant trajectory is along this open pathway. But there have been in the past, and are today, certain areas on the landscape within this type that tend to be more closed. And so there's an alternative succession pathway that gets you over to these closed states. Fire is one of the dominant disturbances in this system, and these are all the fire disturbances that can happen. And so the yellow arrows here are the low severity fires, orange is the mixed severity fires, and red are your higher severity fires. So essentially fire is maintaining an open system, a largely open system. And each of these arrows represents a transition in the model that has an associated probability. So it's a quantitative model. Now, we don't just model fire. We model anything that's important to the ecosystem dynamics. And so in this case, insects and disease are another important factor in Ponderosa pine systems. So these are the insects and disease pathways in this model. Now, in some systems, fire is not an important disturbance. So in our extremely wet or our extremely dry types, you won't see any fire at all. We've modeled everything from prairie dogs to windthrow and everything in between. So whatever is important to the system, we try to represent. We didn't have any, we had a lot of limitations, but that wasn't one of them. So that was a walkthrough, a pictorial walkthrough of what this model is. When we actually model it, we're using a software tool called the Vegetation Dynamics Development Tool, and the model in that interface looks like this. So what I had as pictures before representing the states are now the green boxes, and you have transitions between them that each have an associated probability. And so we simulate this model over time. We run it out for 1,000 years to generate reference conditions. And those reference conditions that we're particularly interested in for LANDFIRE is the percent of those states over time, the average percent in each of the successional states, as well as the fire frequency and severity. And then, not to be forgotten, if you never want to touch another model in your life, you can use the description documents that accompany the model, and these are a fantastic resource. The model really doesn't stand on its own. It's a set of boxes, arrows, and numbers. And so to interpret that, as well as get a lot of other information about that biophysical setting, you can go to the description document. It'll show you who created the model, what assumptions go into that model, what are the major vegetation types, how the successional classes were defined. It's a really great resource, and it's just English. It's a PDF file, and you can get it on our website. So the models were developed through a series of expert workshops that we held during the LANDFIRE National phase, where we went out and we invited anybody that we could get that had some knowledge of these ecosystems and their reference conditions. And so we had folks largely from the federal agencies, also significant participation from nonprofits like NatureServe and the Nature Conservancy, state government, academics. And so these are the folks that contributed to building these models. And I think it's important to say that this model set, more than any other LANDFIRE product, is one that the user community owns, because it's one that the user community built. So it's pretty special, I think, in that way. So we have a number of important ways that we use this model product in LANDFIRE. The first one really is to generate a set of reference conditions that we then compare to current conditions to map vegetation condition class. But it's also used in a number of the other spatial products. So a rule set is developed in those reference condition models from which we map succession class, and then the fire and frequency that we simulate in those models goes into the fire regime products. So those are direct ways that the models relate to the spatial products. But it's also used as an ancillary data source for mapping the existing vegetation type, the biophysical settings map, and the fire behavior fuel models. Okay, so this model set has evolved. Well, the models haven't changed over time, but we've used them in different ways. And I want to cover some of those changes in the way we've used them, because it affects the products that we derive from them. So in LANDFIRE National, we developed our original set of models. It was over 2,000 models, and it represented about 500 biophysical settings. So there are more models than biophysical settings because there are regional variants. Ponderosa pine is not the same in the Northwest as the Southwest. So that's how you get more models than types mapped. Now, the advantage of this system was that there was a lot of regional variation to represent the different conditions that you would find across the country. The downside was that in some cases there was more variation than was needed, and it was kind of confusing and difficult to work with in certain cases. So during our 2001 and 2008 refreshes, those models were grouped and brought down to a group of about 350. So it was a real simplification of the model set. And that was great for some applications because it was fewer models to deal with, and in some cases they were similar to the types that folks were managing for on the ground. It translated really well into how they were operating on the ground. The downside was that you lost some of that regional variation, and reference conditions for one area were being applied to an area that they didn't fit so well. Because of that, for LANDFIRE 10, which is coming out in the spring, we're going back to something closer to that original model set. And so you'll get all that regional variation, and now the onus is on the user if you want to do some grouping, and then you can decide what's appropriate for your landscape and how you want to group things. Okay, and I want to leave you with what I think is a great example of how these models are used beyond LANDFIRE, because they're very important, as you saw, to a number of LANDFIRE products, but they're also used by other folks for various conservation and management applications. And this is some work that some colleagues of mine with the Nature Conservancy in Nevada have done. Louis Provencher, Greg Lowe, and Susan Abel worked with the BLM office in the Bodie Hills to come up with a conservation action plan. And what had happened in this area was The BLM had previously developed a plan, and it went through the NEPA process. It got litigated in court, and they lost. And so the Nature Conservancy actually approached the BLM, specifically Louis, and said, I have a process that I think might help. Can we work with you? And they said yes. And so they began a more stakeholder-driven process that heavily relied on BPS models to develop their plan. And so this picture here on the left is some of the stakeholders in that group that work collaboratively to develop this plan. This is the Bodie Hills. It's in California, but right up against the Nevada border. And it's about 192,000 acres. It's mostly BLM land, although it's also 30% private. So there is significant private land in that area, and so it was very important to make sure that the voice of the private landowners was heard and their interests and livelihoods would be taken into consideration. I'm not going to get into the details of this method in depth, but they call this technique landscape conservation forecasting, and they have a paper out on that. But you can see that it relies on some of the layers that we've been talking about, BPS and S-class. They did not use LANDFIRE spatial data. They had their own, but you could use LANDFIRE data. And then 3 of the 6 steps rely on the ecological models, BPS models. And so first they take essentially the reference condition model, then they model a future condition under a no management scenario, and a future condition under various alternative management strategies. And in the end, and I won't talk about this too much, but it's a neat idea, so I'm going to throw it out there. They tie it to a return on investment, so they are looking for where you can get the most bang for your buck in terms of restoring the landscape. So again, they take these biophysical settings models, and they started with LANDFIRE models, but they reviewed and modified them with local information. They didn't use them as is. So LANDFIRE models were a starting point for them. So they added in their local information to adapt it specifically for the landscape they were working on, and then they added in management actions and costs. And they ran various simulations over time to represent various management actions that you might undertake. And the important thing here is that because they were working with stakeholders, they were able to game out different strategies over time. So it allowed people to say, well, what if we clear cut it all? What if we burn it all? And so on. And so it allowed the group to work through together and kind of see what potentially could happen to the landscape under these various management actions. In the end, what they come up with is for every type on the landscape, they're able to model, well, they map the current condition, which is shown here, but then they model 20 years with no management, and then what's shown here is their 20 years of ecological management scenario, and ecological management also included their goals for fire risk reduction. And so the model was run out, and using the results that were predicted for the landscape, they calculated vegetation condition class. So that's the green, yellow, and red that you're seeing here. And so you can see, for example, the aspen type, which was moderately departed, under their ecological management scenario, they're able to reduce that departure. Some systems, like Wyoming big sage, there's not a whole lot that they were able to do. Then if you dig into their report, system by system, they go through and they've developed a set of management actions that can achieve their goals for ecological management as well as reducing fire risk and maintaining livelihoods. So they have very specific actions in the model, and I've highlighted here that some of those are fire actions. And they've characterized how much they want to treat a year and what the cost is, and then the overall cost. And they're working with a real budget here. So the BLM said, well, we have about this much to spend on this landscape. And so with the model, they're able to track that over time. And so it's a realistic estimate of what they might be able to do given their real world budget. And because of this process, they did develop a conservation action plan, and the BLM is going through the NEPA process right now, and so they haven't been able to work on their landscape yet. I don't know if it's going to be litigated or not, but what we do know is that all stakeholders were at the table when the plan was developed. No one walked out of the room. And because they have this plan that was developed, work is able to move forward on those private lands, and they've already received a $100,000 stimulus funding grant, and they've done some restoration work on wet meadows, which you can see here. So they've already been able, just because they have this plan that was collaboratively developed, to do some work on the ground. And so what's really important, I think, to note here is that models aren't the answer. Models are a really great framework for helping people get on the same page and work through some contentious issues. It helps people voice their ideas and to game things out over time pretty quickly and have a real-time discussion about some of the possibilities under different management scenarios. So they're a great tool in that sense and have been used quite successfully in a number of areas. Louis and some of his colleagues and other folks at the Nature Conservancy have used this same process in other areas. For example, the Cherokee National Forest, Great Basin National Park. I think they've done a similar process on maybe 15 or 16 different areas around the country. So some take-home messages. LANDFIRE's models are great and perhaps the most comprehensive synthesis of pre-settlement ecosystems across the U.S. And they're a really useful planning tool, although generally you're going to have to spend some time, like any product that LANDFIRE or anybody else creates, reviewing and modifying it and making sure it fits your landscape. Most folks to use the models, they're great as a reference condition model, but often people are doing things like I just described, where you're adding in current information to try and look into the future at what's going to happen. And so it's a great start, but oftentimes you'll need to add a little bit more information to use them. And LANDFIRE has developed a couple of different support guides to help folks review and adapt the models and do things like add invasive species and add different management scenarios and such, and those are on the our website. So on landfire.gov you can find the models themselves. That's the one product, because it's not well, actually there's another product there. The reference database, I think, is there, but the models are on landfire.gov, as well as a model search spreadsheet, which can help you find the most applicable model, perhaps for the work that you're interested in. And then on the Nature Conservancy's LANDFIRE site, which is a companion to landfire.gov, we have some of those support materials that I was talking about, the user guides for how to review and adapt models, as well as some application stories about how folks have used them. So that's all I have. I'd love to take some questions if you have any.